The objective of this lesson is to subtract whole numbers up to 10,000 using the standard algorithm. Let's briefly go over some vocabulary you will need to know for this lesson. Decompose. To separate a number into two or more parts. One way to decompose 342 is to separate it into 300 plus 40 plus 2. Difference. The amount that remains after one quantity is subtracted from another. It is the range between two numbers on a number line. For example, in the equation 289 subtract 146 is equal to 143. 143 is the difference. Minuend. The number from which another number is to be subtracted. Subtrahend, a number subtracted from another. In the problem 95 subtract 32, 32 is the subtrahend and 95 is the minuend. Let's start by using our base 10 blocks to represent and solve the problem 854 subtract 627. There are 4 ones, 5 tens, and 8 hundreds. We are going to subtract 627. There are only 4 ones and we need to take away 7 ones. So let's take one of the tens and regroup it into 10 ones. Notice that 10 ones is the same as 1 10, so we can trade it. Now there are 14 ones and we can take away 7. 14 take away 7 leaves 7. Let's look at the tens. We need to take away 2 tens. 4 tens take away 2 tens leaves 2 tens. From the hundreds we need to take away 6. 800 minus 600 leaves 200. The final answer is 227. Let's try another problem. This time we will use the thousand block, which is the same value as 10 hundredths flats. When the hundredths flats are stacked, you can see they are the same. 10 hundredths equals 1,000. Given the problem, the Blue Coastal Country Club purchased 1,438 tennis balls for the members to use. By the end of the year, 975 were accounted for. How many tennis balls were lost during the year? Well, let's analyze the problem. Wouldn't we have to subtract 975 from 1,438 to find how many were lost? Let's set up the problem. We will record 1,438 minus 975. Beginning with the ones column, we need to take away 5 ones, which leaves 3. Now we need to take away 7 tens, but there are only 3 tens, so we decompose one of the hundreds into 10 tens and trade them to the tens column. Now there are 3 hundreds and 13 tens. 13 minus 7 equals 6 tens. Next we need to subtract 900. Since there are only 3 hundreds, we will need to decompose the 1,000 into 10 hundreds and regroup to the hundreds place. Notice that when we stack 10 hundreds, it equals 1,000, so we can trade the 1,000 block for 10 hundredths flats. Now there are 13 hundreds and we can take away 900, leaving 400. There were 463 tennis balls lost during the year. Let's pause to look at this chart. Notice that every time we divide by 10, we have one lower place value. 1 million divided by 10 is 100,000. 100,000 divided by 10 equals 10,000. 10,000 divided by 10 is 1,000. 1,000 divided by 10 equals 100. 100 divided by 10 is 10. And 10 divided by 10 equals 1. Each place value is 10 times less than the value of the previous place. Instead of using base 10 blocks, we can use drawings. The cube represents 1,000, the box represents 100, the stick represents a 10, and the dot represents a 1. Here's another problem. The Brock family purchased all new appliances for their new home. The total cost of the items shown is $2,934, but the store was having a sale. The Brocks were able to take $586 off the total cost. How much did the Brocks spend on the new appliances? It looks like this is another subtraction problem because the Brocks were taking money from the total cost. So let's make our problem using the drawings. 2 thousands, 9 hundreds, 3 tens, and 4 ones. I usually write my pictures in groups of 5 so it looks like the 10 frame that students know. Next to it, we'll write the algorithm as we do the drawings. 2,934 and subtract 586 and the equal sign. So we will have to take away 6 ones. Since there are not 6 ones, we can decompose one of the 10s into 10 ones, which now belong in the ones column. Now we have 14 ones and can take away 6, leaving 8 ones. Looking at the algorithm, we decomposed one of the 10s into 10 ones, leaving 2 10s and making 14 ones. 14 minus 6 is 8. Next, look at the tens place. There are 2 10s and we need to take away 8 10s. So let's decompose one of the hundreds boxes into 10 sticks and combine them with the other 2 sticks. There are now 12 10s. Now take away 8 10s to get 4 10s. Looking at the algorithm, we decomposed 100 into 10 10s, which left 812 10s. 12 10s minus 8 10s is 4 10s. Let's look at the hundreds boxes. We have 8 and we need to take away 3. We won't need to regroup here. 800 minus 500 leaves 300. And we don't need to subtract anything from 2,000, so our answer is 2,348. Back to the algorithm. We worked in the hundreds place and found there was no need to regroup, so we subtracted 5 from 8, which equaled 3. Then 2,000 minus nothing left 2,000, and so the answer is 2,348. The Brock family spent $2,348 on new appliances. The objective for this lesson was to subtract whole numbers up to 10,000. The objective was met by first working with manipulatives, the base 10 blocks, to create an understanding of the place values, then extending that to the abstract written algorithm.